All right, welcome back. We are COMP2142. That's Game Artificial Intelligence 1. And that's in the winter 2026 semester at Georgian. And it's week 1, part 1 of our broadcast and recording. So, you know who I am from last day. And I want to talk about AI this week. So, we're going to do a lot in AI. Okay, it's different than the other two courses in that we're combining two things in one. I'm going to teach you guys algorithms and data structures, which you guys need. You won't learn that in any other course, right? So that means things like how to make a tree, how to make a list, how to make a graph, how to do all those things. We'll do it both in C++ and in Blueprints. So we'll do those two things together. So that's one thing you need. And you need to do that because without data structures, you can't really do behavior. So this course isn't about AI behavior. I got to talk about that. It's about AI movement more than anything else. Why? That's why we break these AI down into two courses. AI 1, which is this course, and AI 2, if you're going to third year, you'll have that in the fall of 2026 in the new building. Okay, that's when it's planned to be. All right, so that's what we do behavior. We're going to talk in the behavior section. We're going to talk about decision trees and behavior trees and a bunch of other stuff. But here in this course, we're strictly talking about movement, and we're talking about data structures to get you ready, right? So that's what this course is about. Starting off this week, again, it's a bit of tool setup if you need it. But next week is where the real fun starts. We get into steering behaviors. We talk about kinematic movement, seek, flee, arrive, and wander behaviors is what those are. We'll talk about, ways of me partitioning the world. So if I want to talk about a way of partitioning the world, we've seen them in other games right now where, for example, I can create a grid or I can create a hex map or something like that. And these division schemes, we're going to talk about division schemes, are one of the ways that we use, aside for just simple nodes, because we've done patrol points already. Like, we work together with patrol points. But those are kind of loose nodes all over the place. But now we're talking about, hey, I want to divide or subdivide the world into some kind of grid. How do I do that? How do I use the grid itself, the cells of the grid, to inform what I'm going to do next, right? And I want to create something called smart cells, where each of the cells tells you, or the AI, what to do next. Okay, so that's something that we're going to talk about. So kinematic behaviors are first, then we get into dynamic behaviors, dynamic steering, and then finally into obstacle avoidance. So there's two types of avoidance. There's avoiding an obstacle, which is basically something that is literally static in the world. And then when I'm actually doing, collision avoidance, where there's two things that are moving and I want to avoid colliding with something else that's moving. So two things that are moving together. We will actually create all these from scratch. Like I said, we're not going to be using the navigation system that's built into Unreal Engine. We'll make our own movement system. And so this is where the challenge is for you guys. It becomes more of a programming task and a thinking task, as opposed to, let's just use the tools that come in with Unreal Engine, right? Why? Okay, well, here's why. What if you wanted to make a game that didn't use, as an example, a navigation mesh, like some kind of flight game, right? A game that the navigation mesh doesn't exist. There's nothing to navigate on, right? How do you do that? There's lots of tricks where you can use the navigation mesh. For example, a plane that's really way low down and the massive mesh that takes up a lot of physical space, a volume that is three-dimensional. You could do it that way. And then what you're doing is you are casting down with some kind of like capsule or something that's physically touching that mesh way down on the ground, even though you're far up in the air. And then you can navigate from a two-dimensional perspective. Because all that navigation mesh it does the XY plane. It doesn't really talk about the Z plane at all. Well, how do you do the Z stuff, right? That's more challenging. You could use multiple navigation meshes, across two axes, like the Z axis as an example, and then the XY plane. And then what you can do is cast in both directions, almost like shadows, where you're doing that kind of stuff. And you can do really interesting things. Or you can subdivide the world into, a grid, an invisible grid that you can't see. No one can see it, of course. It's not really being rendered, but then you can use it almost like as to going from one grid cell to another, right, in 3 dimensions. So you can't do 3 dimensions unless you know how to do 2 dimensions, and so that's why we're going to do 2 dimensions today, or not today, but this semester. And I mean that in terms of the XY plane. We're still going to use a 3-dimensional project, a 3D project, but we're going to use a perspective that looks like 2D. All right, so we're going to work on that in the first half. Data structures we're going to hit in the first class. The first half are sorting algorithms, search algorithms in the first half, and then in the second half we're going to do more. Stacks, queues, linked lists, graphs, all that stuff is going to come in the second half. And again, the intent here is not to bog you down with additional work, but actually to get you to understand how all these structures are used in general purpose languages like C++. Okay, so that's what's happening there. In the second half, it's mostly devoted to pathfinding. So you make your own pathfinding algorithm. Like we said, we're going to talk about Dijkstra's algorithm, which is kind of like the original pathfinding algorithm that came out. I would say one of the first ones. It's a greedy algorithm that tries to find the shortest path between A and B. We're going to talk about that. And then an optimization pattern called A-star pathfinding, which is what NavMesh uses today in Unreal Engine and in Unity and in other places as well. And if you were going to make something, you would kind of make it that way as well. Navigation Mesh we'll revisit in week 11, but we'll add modifiers to it. We'll add a bunch of stuff that you can do with NavMesh. We'll talk about hierarchical pathfinding as well. We'll talk about path smoothing in week 12. And as we progress, you're going to see that, for example, in week 12, path smoothing, it falls on our Good Friday, right? So the day that we're off because of the Easter holiday. So we won't have class during that week. It'll be async, which means I'll record the class and you guys can watch it. Remember that all of these things, path smoothing and all that kind of stuff, could be something that's viable for a test requirement or whatever. The structure of the projects and everything else are like this. So slightly differently, instead of like having 4 assignments, 1, 2, 3, 4, you actually have 2 assignments broken up into 2 parts. The first part, 1A, is steering behaviors, where we start kind of developing, the structure of the project. I will help you, I'll guide you through everything for all these assignments. These are guided assignments, and I mean that in terms of, I'll give you part of it, and then you do the next part. You can't, honestly, I would love to say, just go do it. It's not possible. There's a lot to do, honestly, within the time we have. So I will guide you through each of the labs we get to. There won't be a in-class exercise, but I'll give you the piece parts you need for your assignment. So if you miss a lab, that's bad. Because then you're like, well, how do I do that? Well, you have to watch my video and waste 3 hours of your time. Please don't do that. Come to class, get as much as you can. I will post stuff on DevOps, and all the stuff I post on DevOps for this course will be 100% aligned towards your assignments. Like there won't be like random stuff that we're talking about, right? So midterm tests will be covering everything from weeks 1 to 6, and then your final test is, like I said, from weeks 8 to 13. And those are worth 20%, but actually, as I said on the last couple of days, on Wednesday and Thursday, it's all group work. So teams of up to 2, please sign up for the same groups. I recommend. You don't have to. If you want to do, if you're like I said, a solo artist and you want to do it on your own somehow, solo coder, if you will, then you could certainly do that, right? But I highly recommend you combine with other people, because there's a lot of work for one person to do 3 assignments every couple weeks, right? All right, that's what it looks like it's going to be. So please sign up today if you haven't had a chance to do that already. So I'm excited about this course because this is one of my favorite courses to teach, and I'll tell you why. Because again, everything's from scratch. We do everything in C++ and in Blueprints. I'm going to give you challenges where I say, okay, so you've got your C++, convert this to a blueprint. How do you do that, right? And it'll be one of the challenges of the day. Or you've got your blueprint, convert this to C++. At the end of this course, what I really want you to be is more fluent of doing that. People asked earlier this week, hey, do I have to use C++, for this semester? And the answer is, well, there's certain parts you do, and this is one of the courses where you need C++, because we're going to build a priority queue. So a priority queue is a special data structure that prioritizes nodes or anything you feed into it, from smallest, or it kind of sorts them, and so you need to know sorting from lowest to highest. So why do I need that? Well, if I'm doing pathfinding, I want to find the shortest path, and for example, if I have a path between me and you, and that path length is, let's say, 3 meters or whatever it's going to be, something like that. But then if I go from me to Griffin and that path length is like, let's say 4 or 5 meters, let's say from me to him, right? Then if I sort the 2 paths, I'm going to choose between these 2 paths, then your path is first and then his. So that's how I'm going to choose between which path I'm going to try out first. I need a priority queue for this. Why? Because I'm going to sort out 200 nodes, right? So I've got all these nodes and I want to find the shortest path from A to B or from B to A or from wherever, right? And there's lots of stuff like that that we're going to explore, but we need to build up those algorithms in order for us to understand how to do that. And we need to do that in C++, okay? So that's what we're doing. Assignment videos are like we talked about before. I'm going to skip all this stuff, and I'm going to go right down to this part, which is what we're going to be doing today. Now it says more C++ for Unreal Engine. I want to talk about actually, I've modified this for this week. I really want to talk about custom collision detection today, okay? Because we need it. Here's a challenge that you guys have always had, right? And I mean, I'm using all these 3 courses to kind of give you as much as I can for your level up and rise stuff is what I'm trying to hopefully help you with. So here's the problem that we've always had. I'm going to talk about it later on today, which is casting. Casting is an expensive exercise. Every single time we cast from a regular actor to a player controller or something weird, it costs a lot of, it's computationally expensive. So how can we avoid casting? Custom collision detection, custom objects for each object. So instead of using pawn and a bunch of other stuff, I'm going to show you today how to do your own custom objects, right? Which is going to really help you with collision detection. It's going to ease us doing the collision detection stuff, which is always a pain in the ass with Unreal Engine because of all those different collision profiles that you have to dig through, which is a pain for students. So we're going to talk about that, how to do that, and hopefully that'll help you with this course and the others. So that's what we're doing today. Questions before we move on. And hopefully we'll get out of here early today because some of this, as you'll see, is some theory we need to talk about. And then one thing that I have to talk about with these courses are, I'm not saying they're super theory heavy, but we need to talk about some theory. You need to understand the basics, right? So we can't just like, okay, let's just do it, right? And then you don't know what I'm doing really, right? So, and the other thing I want as an outcome from this course is anything we learn in these courses can be transferred to Unity or to your own engine, again, if you go to 3rd year, okay, when you build your own engine with Connor, okay? All right, let's move and get this done. So let's talk about artificial intelligence in general. Well, we've been seeing AI for a long, long time now, especially the last few years with, the emergence of large language models and that kind of stuff. It's become prevalent in our lives, as an example. I know a lot of people already have given themselves over to the AI. They don't think anymore. Well, I need to go to my stomach hurts. What should I do, AI? Maybe you want to go to the washroom? I'm serious. They ask questions of the AI that they can probably figure it out on their own, right? And everything from, I want to send an email. Oh, I'm afraid to send the email. It's not good enough. Let's see my AI. Let's get it to vet the email. Because if I don't get to vet the email, then I'm not sending a good one, right? The AI can clean that up, right? Or I want to make a selection. I want to buy some winter boots, right? And you know what? This is my foot size, and I'm looking for this kind of stuff. What do you recommend? And they're going to that more nowadays with large language models than doing something like searching on Google. One thing that I saw yesterday was the decline of Stack Overflow. Have you guys seen this map? Right. So Stack Overflow, which is a way of finding, code solutions to coding problems, was a big site that was used for a long time. But ever since ChatGPT was introduced, the decline of and death, I would say now, of Stack Overflow is pretty much here, right? Why? Because who the heck was going to go to Stack Overflow? We can just put your question into any large language model, whether it's Claude, Sonnet now, 4.5, ChatGPT 5.2, right? Gemini, which is integrated with your Google, or anything else. It'll give you the answer instantly, as opposed to you going to, Stack Overflow. Yes?
I just use Reddit instead of Stack Overflow.
Sure, but one day Reddit will be something else. Think about what we have right now, what we're doing, right? We have this, let's just call it the algorithm, all right? I know it's really weird, like Big Brother. I know, it's spacey, right? We have the algorithm, right? And what we're doing is we're feeding it data constantly, every single day. Every one of us. Every time we go and search something or whatever, you know, Gemini is collecting this data, and whatever you're searching for, it's getting better and better at suggesting stuff back to you. Before, it wasn't like that with Google, the search, right? And the same thing with ChatGPT. Anything you put in ChatGPT or whatever, it's using the stuff that you're putting in there, and it's actually getting better at suggesting solutions to you, right? Especially if you say, no, you're wrong, it's like this, all right? Which I do often, by the way. No, you're wrong, it's like this. I say that. You gave me this, and now you're giving me this other cockamamie solution, which is actually backtracking to what I asked you before. No, I meant this, right? And the integration of AI in all of our tools, Outlook, Microsoft Office products, Office 365, it's everywhere. Adobe, if you're going to do any kind of Photoshop or whatever, literally large language models have, you know, proliferated every part of our lives, believe it or not. And sometime in the future, I believe, you know, some people are going to give themselves over to the AI. They're just going to, like, you know, literally bow down to the foot of the AI and go, just take me. Because they can't make decisions of their own, right? Because it's easier for someone else to make a decision for you, my friends. Far easier. Do this. And especially if you're certain, there's a level of certainty that you trust. It comes down to trust systems, where you trust our AI masters to do what, you know, to do the right thing, the better thing, the profitable thing, the efficient thing, the optimized thing, right? Well, we can't do that as humans, right? We do things that are emotional things, right? And we do things that, you know, not necessarily the right things. So, it's here. And I know some people are, I talked to Devin the other day, and he was like, AI is going to crumble away. I can't wait for the AI bubble to burst, is what he said, right, Devin? And I'm like, yeah, it's not going to happen. It's going to kind of go over to QIs, you know, quantum intelligences, which is going to happen soon with quantum computing, right? And because people have sunk in, there's like a sunk cost when it comes to this large language model stuff, where big companies continue to sink in billions in terms of everything from data centers, where they're finding things like, look, NVIDIA's boss just came out in CES and said, listen, we were finding a way to cool our data centers with warm water at 45 degrees, all right? They're figuring out ways of making battery-powered things that are using iron instead of, like, you know, lithium and all those kind of things. They're doing all these things because they want to empower AI to live outside of the box that they're in, you know, in some kind of robotic body. Take a look at those Boston Dynamics, you know, examples that we saw at CES this year. And we're going to see robots. You know, I'm telling you guys, I'm not a futurist, but I'm a future believer. And I really do think that in the near future, we're going to have robots part of everything that we do. Robots and AI is going to be everywhere. So why am I saying these things? I don't want to scare anybody, right, or whatever. It's just here, right? I think there's a great ethical use case for AI. I really do, right? Beyond what we're talking about for game artificial intelligence here, right? A really great use case for brainstorming and all that kind of stuff. And I know Devin agrees with that. I have to look, I always say Devin because Devin's the guy, right? But I'm just saying, right? But he agrees with it, and other people agree with it too. If you use it for brainstorming, I think it's okay. I think it's good for, you know, as a, you know, kind of a, you know, just thinking about something like where you're, you know, trying to, you know, think about ideas or whatever. Sometimes, though, I can also tell you that it corrupts your ideas, right? Hey, I'm looking for a name for this, and it's got to be in this context, and it'll give you something cockamamie. It'll say, like, what about this and this? And it's completely wrong, right? Again, the more times you do it, the more data the algorithm has, right? The more accurate it's going to be. Think about this, right? So, I mean, what is it wanting to do is it wants us to use it as much as possible. The more we use it, the more data it has, the more accurate it's going to be, right? And eventually, we're going to come to the point where we trust it very much. That's large language models, but that's not what we're talking about today. Here's something that we want to define for artificial intelligence. We need a definition for what this is. Artificial intelligence is really, like it says here, some kind of process of creating a system that's capable of exhibiting behavior that we perceive as intelligent, okay? It doesn't mean that it's general artificial intelligence. We're not talking about, you know, having a consciousness, okay? That's very far away as far as I'm concerned. I really do believe so. I think the AIs that we're going to see over the next 10 to 20 years are going to be just like large language models, just on steroids. They're going to have a lot of data, more data points than we have today because we just started. Think about the database, this big data idea. that they're continually rolling. So they're going to get more and more. It's going to feel more and more human-like, but they're not going to be general artificial intelligences. They're just going to be, a box that is going to follow an algorithm. And that's why I'm calling it the algorithm. We're going to keep feeding data into the algorithm until, we're so trusting of this algorithm that you're going to have some kind of fanatics. They're going to make groups. Instead of the church of whatever, it's going to be the church of the algorithm. And they're going to, they're going to say, you just trust this thing. It's coming from God or some weird thing like that. And there's going to be people just following their, the AI, right? So, but for now, what we want to think about is that AI for games can make human-like decision-making. It's a simulation more than anything else. It's not true general artificial intelligence. And that's the difference, right? So I think what's really great is how we separate AI and how it becomes useful for us. So let's separate it like this. There are certain things, certain domains where AI can just do things better than humans. Clearly, any kind of computation is something that a computer can do better than us, all right? If you want to compute something, like literally calculate something, they're just better than us, yes?
I've heard it breaking down that, the best way to look at it is that at the core of it, human brains are really good at pattern recognition, whereas the computer is really good at arithmetic.
I like it, but I think computers can be just as good, if not better, than humans at pattern recognition because we miss stuff, right? So, and we miss stuff because of, and I have to tell you this, the reticulum activator in our brains, all right? Oh yeah, I don't know if you guys heard of the reticulum activator. Okay, here's something. You're shopping for, let's talk about those boots, a pair of boots, all right, as an example. And, you're shopping for these pair of boots and they have to be something like you like Doc Martens. Let's just say, I like Doc Martens. So you want to buy a pair of Docs, right, as an example. And you're thinking about the sole of the boot and whatever, you're doing some research, right? And then when you go to a mall with your friend, girlfriend, brothers, sisters, whatever, suddenly you see boots everywhere. You never noticed boots before, right? But now you're noticing people are wearing those boots, the boots that you want, as an example. That's the reticulum activator, all right? I'm interested in buying a car, right? I want to buy an EV because, hey, that's the latest trend. I want to buy an EV. So I start doing some research on EV. I look at the Hyundai, Ioniq 5. I look at the, Ford Mustang Mach-E. I look at the Tesla, Model Y. I look at all these different things. And then suddenly I see EVs everywhere. It's almost like everything is an EV. It's the reticulum activator. I'm trying to sell my house. I see for sale signs everywhere. I never saw them before, but now they're everywhere, right? It's not true. It's because our human attention, what happens is we focus on those things and we see things that we're focused on. So going back to this, we know that humans excel at certain things and we know that computers excel at other things. Computers really excel at computational tasks more than anything else, and pattern recognition is something that they can do really well as long as they have the right data set, okay? But what they don't do well is emotional intelligence. That's where humans are better. We have the emotional intelligence, we have the creativity, and all that kind of stuff. We've created the universe so far, our universe the way it is, right? Some people even think that our brains work at the quantum level, which is way faster than any computer can work right now, right? We don't have to worry about heat for our brains or anything else like that. They work at the speed of thought, right? Which is pretty cool. And they govern a lot of autonomic modules that are inside of our bodies, right? Some people even think, there's some metaphysicists and biologists that really think that we actually live in different universes in our own brains, right? This is a new thing. The quantum universes that our brain crosses over at the quantum level. This whole idea of deja vu, right? As an example, is it that we've been here before, or is it that we're crossing into another, near similar universe? Yes.
Yeah, I've heard even that it's possible that every person's technically immortal, because every single time you in a situation where you could die, if you could survive in that scenario, you will survive because you'll be conscious in the version of events where you survive, but you'll die in the version of where you die. But it doesn't matter because you're not conscious in the universe where you die in, so you're effectively immortal. If that's true.
Well, I like the idea behind it. I think it's a fantastical idea. I love it, right? But for us, we won't be able to live in multiple universes, right? So there will be a death for this version of us, right? If you want to talk about that, but hopefully not anytime soon for any of you, as an example. But one thing that we know for sure is this, all right? Every decision we make, this cause and effect idea, right? If we're going to talk about brains and humans, right? Cause and effect. Every decision you make and every decision you choose not to make creates other decision points, right? I look at it as the cone of reality. This cone that's kind of spans out in front of you, right? And all the decisions that you could make or not make, right? One thing that I've been following a lot of business over the last years, and because I'm an old guy. Andrew keeps saying I'm an old guy, right? It's true. I'm an old guy, right? And one of the things that people say, there's some philosophy around it, and one of the philosophical points is everything that happens to you happens because of you. Right, in one way or the other. Not where you were born and all those kind of things. You can't control those things. But I'm talking from the moment that you're born, everything happens to you, happens because of you in one way or another, right? And so if that's true, so if we make a decision or we choose not to make a decision, it's a choice, and every choice we make, choosing to do something or not make a choice, right, creates more choices, right? And that's something that computers can't handle. They just can't do it that way. They don't have that capacity right now. So again, computers are better at performing data processing analysis, repetitive and routine tasks, mathematical computations, some pattern recognition in large data sets. Small data sets we're really good at, faster than computers are, right? Multitasking and simulations and modeling. That's where computers are better. But humans are far better at creativity and emotional intelligence and generalization, context understanding. Like, that's one of the problems that LLMs don't have. They don't have any context at all. They can't understand what you're trying to tell them. They really don't have an understanding. They're just spitting back out what you're giving them. Yes?
Hence the aspect that they can get, if you're looking for historical information, they can get entirely wildly wrong.
Yes, they can. Yeah, but they're getting better at it. They are getting better at those things. So one thing that we're missing in LLMs is something called a validator, right? And they're getting better at this, almost having like some kind of other engine that validates the fact that the stuff that they're spitting back out to you is right or wrong, right? Almost like a secondary backup or a redundancy of some kind. But they're getting there. Physical dexterity, I think, is still us, but in complex environments. And says, but I really think that fine motor skills are coming to robots. Some of this stuff robots are going to conquer. I'm telling you right now. One of the biggest issues we talk about in artificial intelligence is, autonomous vehicles, autonomous drones, and that kind of stuff, right? I wrote a paper on autonomous warfare. Oh yeah, I did it for university. Where you have an autonomous drone with no human operator, and as long as you give them the right target, they'll go kill people, right? And it's actually a thing. It's actually a thing that they're doing. They've been developing it over years and years. Killer drones. As an example, where you just set a drone free and you're like, yeah, those are the enemies, go get them, kind of thing. And there's no human intervention at all, no human oversight. And you might think that that is really, really far away, right? Huh?
Because it is not at this stage of this game.
It's you know what? So there's a guy that I want to focus on just for a second. And you may know this guy, you may like this guy, hopefully not. You may not like this guy. His name is, Palmer Luckey. All right. This dude, all right? And I want to talk about this guy. If you look this guy up, he talks about how he is 100% interested in creating artificial intelligent drones. That's what he's talked about. He's created new companies. He was one of the original founders of the Oculus, VR headset. He's a very smart man, young as he is, but also wacky in terms of the stuff he talks about. So if you actually listen to this guy, he talks about how he wants to create, he's one of the richest people in the world too. He wants to create these artificially intelligent robots and stuff like that because he thinks one day, I'm going to switch back to this now, he thinks one day it's going to be just like nukes, right? So imagine, we have nuclear weapons in different countries. We don't have any in Canada. We don't have nukes in Canada, but they have nukes in the States and other places, right? So what they do is, they create nukes, and then they're like, well, we're not going to, launch a nuke at you because, deterrent, you're going to launch a nuke back at me and we're going to kill each other, right? Well, now let's think about AI as a nuke, right? I can have some kind of AI that's going to attack another country, right? And you might think, well, that's unethical. Why would we ever do that? We would never create an AI because then they can run away from us. Someone's going to do it, guys. And if they do it, that means we're going to do it, right? Because at the end of the day, if we don't, we're just going to be like Canada with no nukes, right? And I'm not saying I support nukes. Not at all. But I'm telling you, that's where it's going to go, right? So it's going to be a deterrent, and he talks about that a lot. He says, like, he envisions China invading Taiwan, right? Where Taiwan is, for a long time, China's been saying that Taiwan is an illegitimate country and it should be part of China and all this kind of stuff. And he can imagine one day where China invades Taiwan. Taiwan is the center for all electronics and chip manufacturing for all over the world, Microsoft, the United States, and everything else. And somehow it destabilizes the world, just the attack from China. He's created this scenario that he talks about. And the way they do that is with AI, right? AI is faster than humans. They can attack faster than humans. We can't respond to them, especially drones and that kind of stuff. Everything is remote, and they have the capability with their manufacturing capacity to take over a country strictly with autonomous, drones. Scary stuff, right?
Going into Star Wars droid warfare now is great.
Well, I don't know about any great warfare. What do they say? Fallout. War is bad, man. So let's go back to reality. Let's pare down to what we're talking about here today. So what do we want to do? What does an AI programmer really want to do? They want to create reliable and efficient AI systems. That's one thing they want to do. They want to enhance the user experience because we're going to use AI in games to really create a challenge for our players. That's what we want to do, right? We want to make, AI agents, if you will, and the AI agents are going to come against our players and create a challenge. And if we're challenged, we want to come back and play the game. That's the idea. If there's no challenge, we're not going to play that game more than once. If there's too much challenge, like for example in Dark Souls, some people can't play Dark Souls games because it's just too challenging. It's too hard for them, so they run away. They never play that game again, right? Yeah.
Notice, like, I had posted a quick break of one AI discrete boss I saw in development for another game coming out.
Mm-hmm.
I think I posted it video in the game on Discord.
Mm-hmm.
Boss called Asterium of the concept of not only is this thing going to be an adaptive enemy, it will remember every encounter it's had for player and use that memory to pay forward to the next time it encounters a player.
Yeah, it's called reinforcement learning.
Yeah.
To me, there's advantage and disadvantage to that. I like the idea behind it, especially if you're a good player. But what if you just messed up?
Yeah, it's just going to remember that mess up and just maximize that mess up every time.
They're going to keep on taking advantage of you. And I'd like sometimes to reset and say hey, I want to start over. All right, I don't want the AI to know me. I don't want the world to understand that I passed through this way. But I understand what you're saying. So the other thing that we want to do is we also want to push the technical boundaries of what we can do. We also want to ensure ethical and responsible AI, right? So things like where we don't compromise the user's privacy. Okay, I'm telling you what I would like you to do if you were working for me. If I had a big studio, I would say ethical AI, guys. Okay, we're not making AI to compromise the user's privacy or security. We don't want to do that. Okay, because you could. You actually could. We definitely want to balance between generality and specialization. Certain kind of AIs are really great at one type of thing and really bad at other things, right? So we want to kind of have an AI agent that can do general things that are very well. One thing that they're starting to use LLMs for, they're starting to really experiment with these, is to use a large language model like ChatGPT to work with NPCs, where your NPC knows a little bit about the world. You program the NPC and it kind of acts like it knows about the world and it has a conversation with you. And you can literally have a conversation without a dialogue tree, right? You feed it some information, you say, this is what you know. You're the NPC and this is how you have to act. And it's something that's starting to come out more and more. We're going to have more interactive NPCs, very soon, I think. I think that's pretty cool. And it can kind of simulate what it would be like to do that. Hopefully it won't screw up and say bad things to you. So game development, what do? They design algorithms for NPCs, non-player characters, right? Again, it simulates intelligent behavior. It includes tasks like pathfinding, decision-making, and adapting to player actions. They implement pathfinding algorithms, especially when you're making your own game engine. So again, in Connor's class, if you guys go to third year, you're going to make your own game engine, and you want to do some pathfinding. Guess what? You can do it yourself. There is no, because you're making your own engine. It's not like an AI system you can tap into. You're going to make your own AI system, right? So, so that's part of what AI programmers do. They also design adaptive systems like motion warping and those things that we've seen before. That's all AI that's in there. They might simulate things like group and crowd dynamics. Like, for example, I always go back to something like Cyberpunk 2077, where you have a bunch of people on the street, and then as you walk through them, they kind of avoid you a lot of times and that kind of stuff. And they have a lot of groups that avoid each other. You don't see, the latest version, they don't walk through each other. But in the first version, you had weird stuff that happened, glitchy stuff that happened in Cyberpunk 2077, right? So, and of course, they implement things like behavior trees and state machines and decision trees and all that kind of stuff as well, right? Behavior trees and state machines and decision trees, they're just different applications of making a good decision. We're not doing that in this course. We're not making decisions necessarily. All we're doing is we're moving and we're finding the shortest path. And I know you're like, wait, we're wasting the entire semester doing that? Yeah. There's a lot to be involved, just moving your guy around, right, and doing it proper. So that's what we're doing in this semester. Also, sometimes what we have is a mechanic, and the designer is going to have an idea of what they want you to do, and as an AI developer, you're going to you have to support that mechanic, and of course do things to enhance immersion and optimize performance, because AI can be computationally heavy. Let's talk about a little bit of a history of AI. I'm going to go really quick here because I don't want to waste a lot of your time. I know some people don't like to do history, but we need it a little bit here. One thing we have to talk about is this idea of automata or mechanical robots that actually existed from the 18th century forward. They almost like clockwork machines. They actually did exist, all right? So where people would come and put together, this is a real thing. They would put together things like kind of robotic instruments. You might see them still, like, some kind of clockwork, mechanism that you might see in an amusement park or whatever. Ha, 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 ha. Someone's laughing at you and you see almost like some kind of mannequin. That's what they kind of look like with mechanical parts inside them to move, right? Well, that stuff's been around for hundreds of years, a couple hundred years now, right? And why? Because, humans have always been fascinated about that one thing that Jackson talked about earlier, which is immortality.
Yeah.
Right? Humans have been fascinated by immortality. They've been thinking about ways of replacing body parts for hundreds and hundreds of years, maybe thousands of years, right? Ever since we came to this planet with the asteroid. I'm joking. But what I'm saying is, humans always trying to find immortality. And even today, why do we have all that plastic surgery and everything else that goes on? It's not just for beauty and for everything else. It's because we want to be immortal, right? We don't want to die. Most of us don't want to die, especially the rich people. They don't want to die, right? So they're finding ways of making themselves live longer. And one of the things they talked about way back in the 18th century was a way of surpassing human life, which is to have a robotic body and some kind of brain. It's not a new thing. A brain that's like a human brain inside of a robotic body to live forever, right? Because we know that our bodies will break down, but perhaps if we house a brain in some kind of weird liquid, and somehow it connects to the body, I feel like I'm thinking about Fallout now, right? But it's possible, right? That's what they were thinking. And so they started making these things. They also want to think about servants. They've been thinking about making these robotic servants to do the jobs that we hate to do forever and ever, right? And anyone have a robot at home? Robot vacuum? I have a robot vacuum, right? So robot vacuums exist. It's been around for a while. How about a robot vacuum cleaner for the pool? Anyone have that? I have that, right? It's actually a really convenient thing. You put a robot in the pool and it goes down and maps out the pool's, the bottom of the pool, and it cleans the pool in 2 hours. I'll tell you, cleaning the pool by yourself is a pain in the ass. All right. So if you've ever done any kind of that work, it's really hard. It's ugly. It's an ugly job, right? I don't want to be a pool boy for anybody. How about that, right? And the robot will do it nicely for me. Okay. A robot for cutting the grass. It exists. Husqvarna. Take a look at it. It's actually a thing that does exist. Yeah.
I just saw one recently in an ad for a robot snowblower.
Yes, there's a robot snowblower. There's robots that are doing these little menial jobs. But if in the future, look, we've been thinking about robots for a very long time, guys. Long time. You know, like for example, a robot to take care of your dog, walk your dog, right? Hold on, a robot to cook for you, clean for you, you know, do all the things that we hate to do. Organize your room, right? Whatever. You know, you can think about robots that do these menial tasks. And they can do them all day long because we have a lot of tasks to do that we hate to do as humans, right? And that's what these guys wanted to do. They wanted to make these clockwork models, right? And whether they're human-like or animal-like, sometimes they wanted to remind themselves of people that they lost, like relatives. So they made a clockwork model of an old aunt or a mother or whatever that would actually have some kind of things that they would record. They could record things back then too, or simulate everything from a baby crying, a clockwork baby, seriously, right, to you know, an animal, favorite animal, companion, like a dog or a cat, or whatever. So that's where it came from. The ability for us to give inanimate objects life. Then in the 1940s, I'm going to jump ahead several hundred years to the 1940s, and we started to think about ways of, you know, fighting against each other. You know, cryptography became a thing, right? Especially in World War II, where people were trying to think about ways of communicating with each other in a secure way. Remember, back then, there was no secure communication lines. Radio signals were open. Anyone can listen in, right? Even today, you can still do that. You can still listen in to radio signals, like the radio signals from your cell phone. It's still possible, except it's encrypted now, right? And so back in the day, they would want to decrypt the communications that would go across communication lines, and they used this device to encrypt them, right? So of course, encryption and decryption became a thing. This guy here, Turing, he's famous for, in many ways, the Turing test and the Turing machine. He is widely believed to be the father of AI, right? Because he started to think about how to create, you know, computers that not only could decipher things, but also follow a table of rules to, you know, to kind of perform some task. Okay, that's what he wanted to do. He authored this paper in 1950 called Computing Machinery and Intelligence, and where he considered the question, can machines think? So this is another thing. If we think about this together, thinking, what is thought? You know, where does our consciousness live? Is it in our mind? Is it in our hearts? Where is it? You know, if you know, if you die and somehow you're revivified, you're brought back to life, you know, let's say 100 years later, can you still think? You know, is it the process of neurochemical transfer of communication? Is that how we do it, right? Scientists believe that that's where it happens in the brain, right? And, well, how do machines think? What is thinking anyway, quote unquote? We've relabeled I'm thinking. What does that mean for a machine, right? So that's what he talked about. He devised the Turing test. And the Turing test was basically this, you know, can I create a test where, you know, the machine, if the machine passes the Turing test, and if it's indistinguishable from that of a human, then again, the idea is that they've passed the Turing test, and that means they're an intelligent machine. And the test is based on a controversial game known as the imitation game. So this is kind of interesting. The imitation game is actually a movie as well, if you actually looked at this. So this is how it works. So you have a participant, a human evaluator or a judge, right? A human participant and a machine, the AI being tested, okay? And the setup, the evaluator communicates with the human and the machine through a text-based interface, so they can't see each other, all right, as an example. And to avoid bias from physical appearance or voice. And the goal is the machine tries to convince the evaluator that it is human, and the evaluator attempts to determine which participant is the machine. By the way, there's a lot of times in this test where we think the human is a machine. Believe it or not, because especially now with LLMs and stuff like that, right? So machine is set to pass the Turing test if the evaluator cannot reliably distinguish between the human and the machine after repeated interactions. So that's the idea behind it. So John Searle, he was another philosopher, back in this time. In 1980, he came up with this another idea, which is like, yeah, you know what, the Turing test is bullshit. You know, that's what he kind of said, right? And he came up with this another idea called the Chinese room. And he talked about symbology, right? If you can basically, you know, you can fool, you know, the evaluator easily. And he kind of came up with this idea here. This is a thought experiment that he came up with. So here's how it works. Syntax is not semantics. Computers manipulate symbols, that's syntax, based on rules, but lack understanding. There's no context, right? They don't understand the context part. And computers can simulate understanding by following algorithms, but do not truly understand or have consciousness. Human understanding is different because we genuinely understand, you know, what's required. It's not just about processing symbols. And that's what his argument was, okay, you know, from a very high level. Let's talk about the difference between strong AI and weak AI, okay? So strong AI refers to AI that is truly intelligent, general artificial intelligence. That's what strong AI is, right? And sometimes it's also called artificial general intelligence, AGI, right? And it can perform any intellectual task a human can, and it feels like a human. It might have emotions, all kinds of stuff. That might be something like artificial general intelligence, strong AI. Weak AI, on the other hand, is simulation. The AI is a simulation that makes us feel like it's human-like, right? And it's really great at performing certain tasks or some kind of, or operating in a certain domain, but it has a very narrow intelligence. It doesn't understand everything. Okay, now let's go back. Is an LLM, a large language model like ChatGPT or Gemini or Claude Sonnet or DeepSeek or any of the other ones that are out there right now, is that strong AI or is that weak AI? Yep. Weak, my friends. It's weak AI. It's even though it feels like it knows everything, and Grok, you know, the people at you know, our friend Elon Musk, he feels like Grok is the most intelligent of them all. By the way, it's the worst one that I've ever used, right? But it's just a sales pitch, at least for now. Apparently, he thinks it should have like 3 PhDs or something like that, or whatever.
Yeah, all we've
right?
been doing recently on Twitter is generating Nazi work stuff.
It's terrible. It's terrible. But anyways, even though it feels like, you know, it knows everything, right? It often gets it wrong. More wrong than you and I would get it wrong, okay? However, it's really good at, what weak AI is really good at for now is, it can really give you a quick answer to your question. Where, when you're searching before on Google, you had to look at a bunch of links that matched your search criteria. And then you could read articles yourself. You'd have to actually do some reading about stuff that it gave you. Now you don't have to do any of that. It's just going to spit stuff out at you. And for the most part, it can sound really convincing that it's right. Okay? So that's what it can do. It's great at certain tasks. For example, it understands where to look for things like law in the law domain, okay? In the medical domain. It knows how to do those things a little bit. I'm not sure I would trust it 100% though, all right? At least this, remember, data points. Our algorithm right now in 2026, it doesn't have all the data points from everything, right? Eventually it's gonna get better, but right now it doesn't know everything. It has these narrow little lanes that it runs really well in. Coding, for the most part, it codes pretty good, okay? I'll have to tell you right now, any one of those models, even Grok, for the most part, code's okay, okay? I'm not gonna tell you it's perfect, and sometimes the code it spits out is bad, but it still does the task. If you want it to actually do the task that you're asking it to do, it will do it today, right? But you may need to work with it to make it better, okay? Eventually, it's gonna give you some great code, you know, that's, it's gonna be efficient, it's gonna be the way you want it. For example, if I ask ChatGPT for a piece of code, it'll give it to me with curly braces on the same line as an if statement. I don't like that. So I have to tell it, no, I want curly braces on their own lines. The way it's formatted is wrong, right? It uses variable names that are super short, like opt instead of options. Why does it do that? Because someone else out there has done that. So it looks at, you know, the data set and it's like, hey, a lot of people are using these short forms like O for options instead of options. We don't need to shorten the names, right? And a bunch of other weird stuff. But in general, it will, it's sufficient to the task. Here's something that it can also do, large language models, right? If you take a large language, take your blood test and you take a picture of it or you load it into a large language model, it will interpret it for you pretty accurately, believe it or not, okay? But the question is, should you listen to it? What's the blood test for? Why did your doctor get, your blood test ordered in the first place? Those are things you should consider. So one thing that large language models don't do is they really don't understand, they don't have a good context, so that's why they're considered, for now, weak AI. Let's go back to the symbolic era. So again, back into the 1950s, right? We're into the 1950s again. And they started thinking about creating, more intelligent systems, and they were thinking about ways of doing this. And so they started thinking about symbols, right? Such as words or numbers or sentences or pictures, right? That kind of stuff. And basically a reasoning algorithm would manipulate those symbols and generate new combinations, and they were meant to represent problem solutions or new knowledge. This is where, if you think about it, large language models come from today, right? The symbolic era, kind of idea that they had way back in the 1950s. This is not new, okay? So again, the most famous symbolic AI was kind of like an expert system, and they kind of used if-then rules. A good example of that might be a chess program. Symbolic, right? Where you could make a chess program to beat the human, right? And why? Because you're going to program it with if-then rules, right? And sometimes the chess program will do weird, wacky stuff that you would never do as a human, right? So that's something that is something that we're able to do. So symbolic systems, again, a key insight for this is symbolic AI is a trade-off between knowledge and reasoning, right? How much knowledge does it have and how much it can reason based on the if-then-else rules that it's been given in its database, right? Then, as we came into the 1980s and extended into the early 1990s, we had this idea of the natural era, right? Symbolic AI was really struggling, to scale more complex tasks, and what it did instead was, it wasn't able to. It could understand basic sentences, but when you beyond that, it was hard, as an example, to get through that. So the natural era came about where we tried to figure out ways of creating a neural network. So a neural network is interesting because they're like, wait a minute, humans, right? What we do is we have neurons, right? And we have a group of neurons in our brain, and the neurons are able to remember things, right? As an example. Well, maybe we can create something similar with AI. So actually, neural networks in general is, we were talking about this with Wallace just before we started this class. If I was going to start a machine learning class, it's like statistics on steroids. Neural networks is a real thing. It does some really cool classification and stuff like that. And it's really great at doing things like classifying. So what I mean by classifying is this. I do facial recognition, neural networks. Is this a dog or a cat? I use data points, right? Is this, a human or is it something else? What kind of plant is this? Neural networks. It's really great at doing that kind of stuff. And the way it works is you have this idea of a hidden layer, where you have input and output, and this hidden layer is almost like this black box that does all the computations for you, and that's how it works. It works very similar to a neuron, okay? So the natural era is where this came from. So natural computing, if you will, right? Other things that we use them for are genetic algorithms, right? So inspired from natural selection. So things like procedural content generation. That's more of a genetic algorithm that we use, yeah.
The diagram hurts me because
I know.
aren't all the input nodes supposed to be connected to every other hidden node?
Yes. Sorry. Sometimes I got to put some stuff together, but yes, it's true. Yes. Yes, yeah. I did some stuff here. I was trying to put some stuff together. I'm sorry to hurt you.
Never do one again.
Then, as we left the natural era, AI research kept on transitioning, and we transitioned to the modern era around 1990, where we started talking about machine learning. Now, machine learning, you might have only heard about it lately, right? But it's been around since I started university way back then, right? And it was in its infancy back then. They had a lot of things that were going for an array. They were starting to think about ways of creating more complex algorithms that were able to do some thinking, right? So the modern era included a lot of things. One thing that we talked about was this idea of using AI to predict the future, right? That's what we want to use AI for. So what they do is use a regression algorithm. We give it a bunch of data points, and it finds a line of best fit. Okay, that's really the regression algorithm we're talking about, right? And with that line of best fit, even with data that's missing, I can calculate future data based on the previous data that I've been given, right? It's a very common, kind of computing example. So I've been working on a project. This is a real thing from last semester. It's called Smart Beach. It's a real thing, right? It's a project that's been ongoing up in Saugan Shores in Port Elgin. I'm not sure if you know Port Elgin, way out there. Real thing, right? So Port Elgin, they've got these beaches out there, beautiful beaches, but they can be quite dangerous because the wave levels are quite high. So what we've done is we've put in a buoy inside the water with some special electronics to measure wave height, water temperature, wind temperature, ambient temperature, a bunch of stuff like that, wind gusts and stuff like this. And they've collected all that data and created a model. And this model is with all the data that we've collected over the summer, should be able to calculate wave height and how dangerous of beaches to be on, because up in Port Elgin, there's not always a lifeguard, right? And there's sometimes people will swim in odd hours, nighttime and whatever, and they can put themselves at risk because of things like the undertow and a bunch of stuff that's going on, right? So AI can be used to, now that we've collected data with a buoy, we can use things like the weather network to give us the data points that we need, right, to predict, if a beach is safe to swim at or not. And by the way, this is a real project that I'm working on right now. We're starting it next week again. We have a researcher that's in Italy, right, from, I think he's from the University of Windsor, that he's out in Italy right now. One of our main investigators in this thing. And we're continuously putting together this new data. We're going to come up with an app this year that basically is going to help us, for the people at Port Elgin. This is our first prototype. It's going to help us determine whether it's safe to swim or not. And we can replicate this data all over the world. Seriously, no joke. It's a real thing, right? This is where machine learning is really great at, right? It's good at regression type of algorithms. It's really statistics on steroids. I'm taking in data points, and then I can use those data points to predict other possible scenarios based on the same independent variables. Okay, let's go back to this. There's two types of variables that we're talking about with machine learning: independent variables and dependent variables. Independent variables are all things like ambient temperature, wave height, all those things we talked about. The dependent variables are like a classification. Is it safe to swim? Yes or no? It's a Boolean. Yes or no? Is it safe to swim? That's the dependent variable. I can't know if it's safe to swim unless I have data from all the independent variables that I need. Okay? So, the modern era moved us from the natural era and the symbolic era into the machine learning era, and we started thinking about using things like support vector machines, decision forests, decision trees, and most notably this idea of deep learning, right, have really driven AI, right? So deep neural networks, or DNNs, they're really transformative, and the reason why is because they can leverage this large scale data and computational power to really handle complex tasks a lot better than what we had before. Convolutional neural networks, or CNNs, really great at image recognition. Okay, so they can take an image and really understand, what it is. Right, they can kind of identify it based on the data set. And then RNNs, or recurrent neural networks. For example, transformers are the successors of those. They really are great for natural language processing. So natural language processing was first used with things like that you know of, like Alexa or Google Home. Okay? For example, here's the natural language processing thing. Alexa, what's the weather today? All right? That's a very common thing. So what does Alexa do? Alexa is the activation word. It activates it's always listening, by the way, if you have an Alexa at home, right? And then it says, what's the weather today? Okay? Weather is the intent, when, today, and wherever you're calling from. So that's what it does. It really feels like it's natural language, but all it does is focuses on those keywords to give you back the thing that you're looking for. That's what Alexa used to be like. Now, we're at Alexa Plus, my friends, where you can talk to Alexa just like you can with ChatGPT. Try it out if you haven't had a chance to see that. Oh yeah, it's there in everyone's home. So if you've got Alexa, you've got access to Alexa Plus. And same thing with Google Home. One thing I haven't covered here are this idea of transformers. And the transformers are the large language models that are out there today. So we're going to see more and more of these transformer models come out that are more efficient. And we've seen them over time. And this is the big hubbub right now. This is the big conversation, the stuff that we're having about how we can use AI to be ethical, right, or not. This idea of AI art in our games, that it's not a good thing, right? People are generally, especially gamers and younger people, are generally against AI art, right? And why? Because it kills jobs. Here's a real, real life story that came out today. I just found out today that Tailwind CSS. I don't know if anyone has done any kind of web programming in the past. There's some great CSS frameworks. CSS is a language or a script that's used for presentation in the web. So Tailwind CSS, what they were doing is it was an open source framework for presentations, the presentation framework for the web. And the only way they made their money is by selling their documentation at a premium. Someone went through and converted all their documentation from their websites to a flat file and fed it into the AI. And now, over the last 6 months, they've lost 80% of their customers. And so they've laid off today 75% of their people, right? And that's because of unethical use of AI, okay? And this is the kind of stuff that we're going to hear about more and more, right? A lot of people have let a lot of people go. Like we saw Microsoft laid off, 5,000 people, 10,000 people last year. And a lot of other companies are starting to lay off more and more people because they feel like the AI can do it faster. Realistically, let's be real, guys, the people in this class right now. Do you think that you could code faster with AI? Yeah.
I think you can go faster, but the job might not be as good.
May not be as good, okay. But what about you filling in the role of multiple people? Do you think you can do that now with your AI? How about a person who's an expert, okay? Okay, I don't want to talk about myself, but I'll tell you right now, let's talk about myself for a second, right? Yeah. I can code 10 times faster with AI. Not 5 times, 10 times, right? In a short day, I can come up with a whole feature that it would take me weeks to come up with. 100%, right? Not because I'm an expert, but because I know what to ask and I know what's right and what's wrong when I'm looking at something, right? And I'm not even truly an expert. Let's look at those people who work as subject matter experts in a specific field. Guys, they could code way faster with AI right now than they ever could before. It could troubleshoot for them, do debugging for them, do a lot of stuff, make some code suggestions, even clean up their code and make their code more efficient, and pass any code review that their managers are asking for. So imagine that, instead of me having a team of people in a room, this is the old days, where I might have 800 people coding. Now I only need 200 people. And those 200 people are going to be way faster and more efficient than the 800 people that we had before. Now, is that ethical use of AI? It's the question that we're going to be answering, guys, for over the next 10 years. All you guys are going to answer those questions on your own. You're going to be asked that question. You're going to be faced with, if you're a developer, especially if you're a game programmer or something like that question. I want to make a game. I don't have an artist, right? And I have this idea, and getting an artist is going to be expensive. Should I hire an artist, or should I put out my game in early access with AI art and try and sell it and make some money? And when I get money, then I'll get some artists. It's going to be an ethical dilemma for some of you. And some of you may choose AI, right? So we'll see what happens in the future, but it's coming. All right. I want to really take a short break. We're sitting at Game AI, and I want to talk about more about AI afterwards. So let's take a short break. Let's take 10 minutes. We'll come back, and we'll talk about Game AI and some of the stuff that I've seen over the years. And I want to talk to you guys about things you've seen, things you like, and things you really don't like about AI in games. Okay, we'll talk about that in about 10 minutes.